Now let's take what we know about solving right triangles and use those techniques to solve navigation problems. When we talk about navigation, we talk about bearings, and bearings are an acute angle measured from the north or south line and measured toward the east or west. So first, let's remember our cardinal directions. North is marked, and then we have east, south, and west. So if we are given the bearings north, 87 degrees east, that means that we will first face the north direction and then turn toward the east direction 87 degrees, measured from that north line. So 87 degrees. And so this would, from this origin point, facing down this ray, would yield our north 87 degrees east. If we were looking at, say, south 60 degrees west, we would start looking down the south direction, but then move towards the west 60 degrees. And so that angle would be 60 degrees. Let's say that we want to look at north 40 degrees west. Then we would look down the north and then turn towards the west 40 degrees. So toward the west 40 degrees. So this angle would be 40 degrees. Notice the angle is always measured from north or south. We never write east 30 degrees north. That's never done. So let's take a look at an example. Here we have a ship that leaves port and travels 25 nautical miles at a bearing south 36 degrees west. So what I do first is I start to draw a picture. After I've read the problem, I draw a picture. So we have our ship that leaves port. So let's draw port. And then it's going to head out on a bearing of south and then west. So I'll draw my cardinal directions as crosshairs over port. Mark out north, and then I know that from port the ship is going to be traveling 36 degrees west of south. So we look down the south and then move toward the west direction 36 degrees. So this angle is 36 degrees. And we know that the length that it travels, so this is port, this is the ship, and it's at 25 nautical miles. And we want to know how far south and how far west did it travel. So we want to know this distance and this distance. And so we have a right triangle, and we know the hypotenuse of that right triangle is 35, and we know the top angle here is 36 degrees. So we know that sine of 36 degrees is equal to x over 25, which means that x equals 25 times the sine of 36 degrees if I multiply both sides by 25. So this means x is approximately, now make sure that your calculator is in degree mode, and you obtain 14.7, and the units for this will be nautical miles. And this is 14.7 nautical miles west. Likewise, we have cosine of 36 degrees will equal y over 25. So y equals 25 cosine of 36 degrees, which means that y is approximately 20.2 nautical miles south. And then one final question was asked is, what would the bearings be required in order to return? So if we take and look at the crosshairs drawn where the ship is, the question is now, how do I get from the ship to port? And we measure from north, so we'll be looking at this angle right here. So this angle corresponds to this angle by our geometry, knowing that they are alternate interior angles. And since we are looking at the north-south line here, which is parallel to the north-south line here, if we have parallel lines, then alternate interior angles are congruent. So we have a measure of 36 degrees here, which means that the bearings to return would be north 36 degrees east to get back.